Welcome to the next video of Chapter 5, which is going to review simplifying square roots and then using the square root method to solve quadratic equations. So let's start out with reviewing simplifying square roots. This is something you learned in Algebra 1 and you reviewed a little bit in geometry. There are two different methods. I'm going to show you both and then you can pick the method that you prefer. We're going to start by simplifying the square root of 48. First method is to look for pairs. So what we need to do is break down 48 as much as we can. I know that 48 is 4 times 12. I know that 4 is 2 times 2. And I know that 12 is 4 times 3. This 4 can be broken down to 2 and 2. Okay, so again, you're just breaking down as much as you can. You are looking for any pair of numbers that are the same. So I have a pair of 2's here, I have a pair of 2's, and I have a 3 that's left over. These you can ignore because you broke them down. So as soon as a number gets broken down, you're done with it. Now here's what to do with those pairs. Any number in a pair goes outside. So 1, 2 from the first pair, a 2 from the second pair. That 3 that's left over stays underneath the root. 2 times 2 then will give me 4 root 3. So that's your first method. Second method is using perfect squares. So again, if I look at 48, I need to know a perfect square that goes into 48. Perfect squares would be 1, that's 1 times 1. 2 times 2 is 4, 3 times 3 is 9, 16, 25, etc. We want to know a perfect square that goes into 48. Well, 4 goes in. It's not the biggest perfect square, though. 16 also goes in. So 48 is 16 times 3. Well, the square root of 16 I know is 4, and root 3 comes down. You'll notice you should get the same answer. Now, if you know your perfect squares really well, you might like method 2. Some of us who don't know our perfect squares as well, or they don't come to mind very quickly, method 1 might be better. So we're going to do a few more examples, and then we're going to move on and talk about the square root method. If we look at 40, I like to look for pairs. So I'm going to break down 40. I get 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So again, look for any pairs. I have a pair of 2's. That other 2 doesn't get included. Pair is only 2, so I have 2 2's. This 2 and that 5 are left over. 2 goes outside the root, and the 2 and 5 that are left over stay underneath the root. So I get 2 root 10. This was using method 1. If you wanted to use method 2, 4 is a perfect square. I know that the square root of 4 is 2, and I bring 10 back down. You need to ask yourselves, can we break down 10? Does 10 have any perfect squares in it? No. So again, I don't care the method that you use, whichever method is more convenient to you. This next example you are trying on your own. So pause the video, give this one a try, and come back, please. Okay, I will be checking tomorrow to make sure that you have that problem completed. There's another example if you would like to try it. If you do want to try it, I will tell you you get 15 root 2. 15 root 2. You're going to simplify that square root of 50 and then multiply by 3. So that's an extra example for you to try. That was just a review of simplifying radicals or square roots. What this leads us to is another method of solving quadratic equations, which is called the square root method. So let's keep going. Okay, square root method. Before we go over what it is, I want us to know when we use the square root method. So there are some quadratics that factor, some that don't. Same idea with square root method. Sometimes it's appropriate, sometimes it's not. So when are you going to use the square root method? When you have a squared term but no, I'm going to say singular or linear term. So for this example 5, we have a squared term, but no singular term, no singular x. So we can use the square root method. And you would notice if you tried to factor this, you'd have a difficult time. Okay, so we have the steps here below. First step is to isolate the squared term. So that term that I underlined, we need to get alone. I'm going to subtract 10. I'm not done yet. Got to divide by 2. So we get x minus 1 squared equals 32. That's the first step. Now we need to take the square root of both sides. Now on the left side, what's really nice is the square root and the squaring undo each other. We just get x minus 1. On the right side, we got to break down that 32. Well, I know that 32 is 16 times 2. 16 is 4 and 4. These are 2 and 2. So I have a pair of 2s, and a leftover 2. 1 2 comes outside. Another 2 comes outside. And that 2 that's left over goes underneath the root, which gives me 4 root 2. Okay, so that was just an aside. That's part of this problem. Now, step 3, don't forget the plus or minus. Okay, anytime you take a square root, you always get a positive and a negative answer. And that should make sense. Our x squared tells us that we should get 2 answers, 2 solutions to our problem. So don't forget the plus or minus. Now get x alone. If I add 1, I get 1 plus or minus 4 root 2. Those are not like terms, so please do not combine them. So that's it. You're done. That's the square root method. We're going to do one more example together, and then you all will try one on your own. For example 6, can we use the square root method? Well, we have an x squared but no x, so that tells us yes, we can. X squared, no x, so yes, we can use the square root method. I'm going to start by adding 5 to both sides. So I get 4x squared equals 64. Divide by 4. So I get x squared equals 16. Now I'm ready to take the square root. On the left side, I just get an x. Square root of 16 gives me 4. Don't forget though, when you take a square root, you get a plus or minus. Now you have an example that you are going to try. It's this example right here. So I would like you to try that one on your own. If you want another example before you try that one, keep watching. Otherwise, finish this example, or really start it and finish it, and turn the notes in. If you want to see one more example though, this is an optional last example for you. So again, get the square root alone. I'm going to subtract 3. And I get 27. I'm going to divide by 3. Now is when I'm ready to take a square root. So I get m minus 4 equals 3. Don't forget the plus or minus. If I add 4, I get 4 plus or minus 3. Now, this is a little bit different because those are like terms. I can combine those. I get 4 plus 3, and I get 4 minus 3. 4 plus 3 will give me 7, and 4 minus 3 will give me 1. Okay, when you turn these notes in, I will expect this problem, the one up above, to be completed, as well as the problem on the previous page. If you have any questions, please write them down or send me an email.